Hello and welcome. I'm Bill Wake. We're working on a basic interpreter that was developed with recursive descent parser originally, and we want to change to a parser combinator approach. And I'm taking this opportunity to practice doing evolutionary design. The last couple of weeks we spent doing that same changeover using a pure evolution strategy, just kind of one version smoothly evolving to the next. This time we're going to take a different approach and use the strategy pattern, which is more of a plug-in, and we'll look at the details of that. All right, so our goal is evolve our basic interpreter from recursive descent to parser combinator. Interpreter, and we've covered this before, but just to catch everybody up to the same level. So an interpreter is a program. It takes another program as input, and then it basically simulates that program, and whenever the program wants input, it goes out and gets some input. Whenever it creates output, it goes and creates some output. And so in effect, you've got a way to run your program. Interpreter looks at a little bit of it at a time and kind of executes it on its own. They're very similar structurally to compilers. So we have the opening up the box. There's interpreter is going to have program text going in. It's going to send it through lexical analysis or scanning or lexing that produces a stream of tokens. And then it goes through syntax analysis, parsing, that produces a tree of nodes. And then we can have an interpreter work with that and the user's input and output. If it were a compiler, we'd have code generation instead of interpretation. So our change, we start with this one, the lexical analysis, recursive descent parser, and interpreter, and we're just swapping out that middle piece. So we're going to start using parser combinators. All right, so the difference of these is, and this is just going to scratch the surface of all this stuff, but at least get us some framing. So recursive descent, you basically start with a grammar. Normally you have to do some work to make it suitable for recursive descent, but it's all fairly mechanical transformations. It's not super hard to do. And if you're used to it, you can write the grammar that way in the first place. So here's an example. An expression goes to a term, plus or minus a term. The braces mean zero or more times. So it's term, minus term, plus term, plus term, plus term, plus term. All those kind of possibilities are in there. All right, and to write recursive descent, you do a transformation, mostly mechanical, not completely, but the left-hand side, we use that as the name of the function. And then on the right-hand side, if you ever reference a non-terminal like term, you call it. So var result equals term, that blue phrase there. Then you have the braces, zero or more times. Well, that's like a while loop. And we have a condition. We've designed our grammar so we can tell from the very first character, are we on the, should we do this rule? So if we see a token plus or a token being minus, then we're going to read that token, save it as the operator and do next token. So we're ready to look for the term. And then we do the non-terminal says call that function. So we call term. And then we're producing a result. The operator op2 is a tree, and it's got an operator as the sort of name of it, and then the result on the left and result 2 on the right. So it builds up a tree, and notice it's a while loop. It's accumulating a tree. In the end, we return the result. So to some extent, this mixes the syntax pieces, like calling the non-terminals and terminals. It also can put semantic checking in. We could check, are they both numeric if they're being added and subtracted? And then it puts in this construction piece to build the actual tree, the parse tree. Okay, so I guess I've said all those things. Now the parser combinator approach, the new approach we're taking, we've got a parser combinator library we developed, and you start from the same place, the grammar. So this is the corresponding rule. And notice it looks a lot more like the grammar. I mean, the operators are a little different, and, there's some differences, but you can definitely see the left-hand side of the grammar rule is the name of the parser that handles it. And then the terminals and non-terminals, we call parsers for them. So parser combinator says I build bigger parsers from smaller parsers, and then somewhere you have these kind of root level ones like match that can match a specific token, and so there's a leaf to our tree. Okay, but anyway, they just make a reference to the corresponding one, so we see term, match plus, match minus. Okay, and then this operator ampersand we're using is a separated by operator. It says A and B is A, B, A, B, A, B, A. So term plus term plus term minus term plus term. We're doing that repetition there. So that particular combinator is a little higher level. It's higher level even than the grammar rules, which are pretty high level already. But it's handy because in grammars we often have like things separated by commas or things separated by operators and so on. All right, the or else, that vertical bar, we use that. Our library uses less than bar greater, but it means or. And then finally, this pipe operator, it sends the result to a transformation function, and that's the piece that's going to actually make the tree. So the semantics of building a tree are sort of pulled out from the bulk of the grammar. But in the end, this expression produces a binary tree. So it's a grammar rule that reads tokens and produces a tree. Okay, so all our code now is written in this recursive descent style. I think it's like 700 something lines, okay, of that, including the semantic routines. We want to change this to the new approach, okay? And what we're going to look at is the strategy pattern. So that's a way of building substitutability in. You often hear it called plug-in. If you have plugins in a graphics app or something, they very well may be a strategy pattern. So a strategy pattern, the client code, whatever that is, it is initialized to take a strategy, and then whenever it calls a method that it may, it normally might have done itself, it delegates to the strategy. So if you call F1, it calls the strategies version of F1. Same for F2. Okay. And the key here is this client doesn't know the particular strategy. It just knows the abstract interface of the strategy. It knows it's got an F1 and an F2 method here. Okay. Now, in reality, there are concrete strategies. So you got a couple of strategy classes that implement that interface. And to set this all up, somebody's creating the client. And so we have a method setup client that's going to decide which strategy do you want to use. And it plugs in the one it chooses when it creates the client object. Okay. And typically everything's got exceptions and variations and all that, but typically you call this decide function kind of once. It might be once per user or once per run or something like that. In a big web app, you may be substituting every time a different user logs in or a different class of users or something to decide which version of the system to use. Okay, and the nice thing with this strategy pattern is we're keeping strategy 1 and strategy 2 both around, so we have some flexibility in how we use them. It may be that sometimes strategy 2 is only useful once it's fully developed. Other times you can kind of blend them and develop it more incrementally, kind of like we did last week with the evolutionary design. We started with the original version and we slowly changed all the pieces to the new version, but we can't go back very easily with that approach. We could unwind a bunch of check-ins, but if it were a team with multiple people working or something, it would be trickier. With this way, we have it in a completely separate bit of code, and we can run either strategy, so we can compare them and things like that. All right, so our goal then, or at least our path we're choosing, maybe to say, is we're going to refactor our current approach to use the strategy pattern and then plug in a new parser that calls the parser combinator library. So we have some sort of client code. We need to extract out, we'll extract out the methods that are going to be specific to the strategy basically. So the methods that are going to be on the strategy object, we extract those out, and then we're going to extract a class. So we'll pull out that strategy class and delegate the calls into it. Okay, so we'll do this before we even, I created a separate branch for this project, but that's more for me being able to compare and contrast the different approaches we're taking to evolution. Normally you would do this in the trunk branch. There's no reason not to, because you've got the strategies isolated. All right, but so we've extracted this strategy class, and then we'll pull out an interface for it. So we need F and G. Well, we'll define those up in the strategy interface, and the client depends on the interface, not the concrete classes. So that's the first step, is to just kind of make some room for the strategy. We only have one strategy. It's a little, you wouldn't need a strategy pattern for one strategy usually. All right. The second aspect we want to deal with is the plugin part. So that's saying, how do you set up a new client? Well, the starting point is more like this. We just create the client, and it does its own strategy, it decides its own strategy. Well, we don't want that. We want our setup to be in charge of defining the strategy somehow. Now, I don't know. We may have to modify some of this. We'll see how it goes. But normally I would expect that somebody else makes the decision, which strategy do I use, and then they create the client using that strategy. And you can see here the client now takes a strategy as an argument, and it's a dependency basically, and uses that rather than creating its own. All right, and once we're there, then we're free to develop our new strategy and make it so we can plug in whichever strategy we want. All right, and we'll have this decide method. It can use whatever it wants. I mentioned you could do it by each user gets a different strategy. It could be user classes, so privileged users get one or something like that. It's all up to you what goes on in that decision process. If you're doing it, if you're developing a major changeover, it might be that only the developers and testers might only be the only people that see the new version of the strategy. Yeah. So, all right. Now, we're going to add another restriction to this, just to kind of simulate something that can happen in real life. It's not the case here, but we're going to pretend that the new way can call the old way, but not vice versa. So our new parser will be allowed to call the old parser, but the old parser can't call the new one. And we have mutually recursive routines. So if you have an expression, it can be A plus B and so on, but it also could be A plus B plus parenthesized expression. In other words, the factor grammar rule depends on expression, and expression depends on factors, so they're mutually recursive. So that's a challenge if you have this one-way restriction. I think we can get around it, but in real life you might not be able to. I've definitely seen a couple of times where people got jammed up on that. They couldn't interoperate those two systems, and so you had to start the old way. You had to develop the new way from scratch, more or less. You could still use the pattern. You could still test and kind of measure your progress and everything, but it's tricky if you can't call either way. But we're going to do that as a kind of artificial restriction, and just kind of simulating what happens in real life if you can't do that, working around it. All right. So we are in a new branch, let's see, called strategy. I think I put it, I put the keynote, and I just edited the to-do to say set up the strategy pattern. Well, let's see what we said we would do here. Extract method, extract class, move methods, extract interface. Okay, so let's see, that's extract methods to be abstracted, I guess you'd say. Move methods. To a new strategy object and delegate from old. Extract the strategy interface. And okay. And then we need to set up the parameterized method to plug it in. Parameters method, and then add a decision rule. Well, I guess that's what that is. Okay. Create the new strategy. Okay. Let's see. So here's our existing parser. The real interface in this thing is parse. It says, give me an input string, which is, we're doing a basic interpreter, so it really is one line of text. All right. Give me an input string. I will turn it into a parse. Let's go look at parse. Parse is a structure, and it says, I know the line number and I know the statements that are on this line. And if we go down to statement, it says, okay, a statement could be an error, an assignment, a data, a def, dim, end, for, go sub, and so on. All the possible statements are in this tree. Notice that a lot of dependencies on expression, and at least one place where we depend on statement. So this is an example of that mutual recursion. A statement can be an if, which can also include statements. Okay, and expressions, I think that's up here. Yeah. So expressions, missing number, string, float, also can involve expressions. Okay, and the classic place is the expression trees. You know, they're normally built from other expressions. You know, 3 times 2 plus 3. You know, 3 times 2 is an expression. 3 is an expression, and 3 times 2 plus 3 is an expression. Okay. So the parser interface coming in, it really is the bulk of it. Okay. These aren't, I think for the most part, these could be private, and let's do that and just make sure. I ran the test before we started, so shouldn't take too long. Okay, yeah. So my grammar rule is, this is a single line. It's going to produce a parse tree. And what does it do? It just calls a line, and then it deals with any errors. Okay? And then a line, and again, I'll make it private, just to kind of, I don't think I have to worry about this, but just to kind of demonstrate that it doesn't matter. Okay? A line says, I need to start with an integer, and if I do, I create the line number and check it. Here's semantics. You know, if it's out of range, that's a problem. And then it has statements. So this is, you know, a line in BASIC is a line number followed by statements, which are separated by colons. And at the end, we make sure we're at end of line, because if you read all the statements, there shouldn't be anything left. Okay. And again, it's producing something. In this case, it's producing a parse still. But now statements, well, it produces an array of statements and so on. Everybody gets to produce something. They don't have to be the same thing. Okay. Right. So we are going to, well, it's a very simple interface, isn't it? Okay. So extract methods to be abstracted. I guess we have that. I mean, this is the fundamental entry point for this object. These are helper functions, and we don't even have an initializer. Okay. And down through the rest of these statements, do input, all that, these are all the statements. So basically the rest of this file is the recursive descent stuff. Maybe a few helper routines, but basically each statement has a block of code, print statement, and so on. Okay. Yeah, here's some helpers and expressions. Okay. Well, I don't know where we want to make this come together. I mean, parse is okay. Yeah, it's doing that. Yeah, so I don't know. Maybe my interface is here. If you call parse, maybe it's this. So the lexer makes sense to some degree. But this next token with single line is very much that the way that token is managed is very specific to the recursive descent. It always likes to have something kind of the leading token. Okay, so all right. So trying to straighten this thing out a little bit. I think maybe let's make this. Let's extract a method. And yeah, okay. I'm going to call it parse. And the signature differs, so it's okay. I'm going to move it down. Okay. And I think this is our interface. This is, well, we'll see. We may need to fool around some more, but I think if I call parse, assuming the lexer is set up, it should be fine. It should do the right thing and then, parse the single line, which goes down and does the statements and does the expressions and all that. And so I believe this is the method we want to key off of. All right. So have we done this? Extract the method to be abstracted. Yeah, I think we've done that. Move methods to a new strategy object. Okay. Sorry, let's claim this is done. This is all part of set up the strategy pattern. Extract, and this is just parse. Okay. Now this. All right, our next goal was extract the strategy interface. I'm going to go back to my picture. Okay, so, I should have said extract class and move methods. Yeah, let's be explicit here. Extract class, move methods to new strategy object delegated from old. Okay, so the class we're after then, I think this is the recursive descent parser, is basically all this. Okay, so let's extract class, and I guess he's going to have to know lexer, right? Let's do that. Lexer. Okay. So we'll create a new class. I don't have any tool support for this, so I'm going to make this new file. It's Swift. And I'm going to say recursive descent parser. Maybe I should even say old parser. Well, I'm using parser for this one. Okay, I'm going to do a couple name changes. All right, so this is public class, old parser. All right. I'm going to change this. This is going to become syntax analyzer. Okay. And then I want to extract and move methods. And I'm going to take the chance and do this. Well, let's see. I'll copy all this stuff out. Okay, so this is the sort of safe way to do this when you don't have tool support. All right, so I'm saying I really want a function parse, and okay, he doesn't have next token, so we'll have to get those. Next token, require variable. Those are all part of our old parser. Okay, and you can see we don't have the lexer. Well, we're the token. Okay, so let's pull those fields. We need the lexer. Well, we're also going to need that constant and the token. I think we'll take all this. The difference is the lexer is going to come from somebody. Okay, so lexer, let's set that up as on your way in. So we got this assignment, lexer equals lexer sub input. Let's give old parser a constructor that takes that lexer. So lexer of lexer. Okay, we don't need to define it because it's always going to be given to us. Okay, this should be okay. Let's do a build just to make sure it compiles. Okay, and we'll make sure tests run still. I should have checked in before. All right, so what we've done is we renamed parser to syntax analyzer. We identified parse as the interface method. We extracted the bulk of syntax analyzer to old parser, and we pass in lexer to old parser. Yeah, lots of stuff going on there. Okay, and we're going to the strategy branch. Good. Okay, so now I want to actually do it. Okay, extract the class. We've done that. Move the methods. We've not quite done that. Okay, and I'm going to take these old comments. This stuff was kind of things, possible to-dos for the interpreter itself. Nothing to do with our transition here. So I'll just put them below and leave ours up here. Okay, so move methods, delegate from the old. We haven't delegated yet. All right, but let's give this an init. And let's say parser equals old parser. Oh, we can't do that until we have the lexer. Okay, whoops. Parser equals old parser with the lexer. And we're going to delegate return parser.parse. And we need to declare it up here. Okay. Cannot assign parser as a let. Okay. Make that a var. Kind of doesn't matter, but it's a little annoying. I've just been talking over Kotlin with some other developers, and it has a mechanism to do this kind of thing, one-time assignment. But in our case, it really isn't one time. I don't know. It's okay. All right, so we're calling it. We're delegating to it. All right, let's see if what's up here has no initializers. Yeah, I don't. This is annoying. Right, because we don't define one here, it complains that it's not set up properly, but we don't really care until down here. Okay. Yeah, it may mean we've got some. There's no may about it. It means we got some clunkiness going on here. Okay, but let's just get through. All right, so this should build. No initializers. Oh, sorry. Parser equals that. Okay. Now, I'm not assuming I've got a perfect interface or anything like that. We'll run those tests. But I've got to get something started to make this to move forward. So we've done that. Okay, now nobody is calling this find selected symbol, right? So this, it's being called, the delegate calls it, or the parser. So I'm going to say all these things now can be deleted here. And that was our move method. We did it manually. I left them in place just because, till we get everything straight, it kind of pays. All right. This class becomes much smaller. Okay, we need the lexer. Let's put the parser after the lexer. And this constant is over there. Okay, so this is our basic class. We have a very narrow interface, a one method interface. We may have to do some work on that, but that's okay. This should still pass. Okay, so now what we've done this move method and delegated. Okay, so let's do that. Extract class old parser. Okay, extract the inner. Oh well, let's check in. Delegate from syntax analyzer to old parser. Okay, this is now syntax analyzer. Okay, what's next? Extract the interface. Okay, let's see, in Swift we say protocol parser, and the interface is really this piece. You promise to have a method that takes no arguments and produces a parse. Okay, and this should implement this protocol. And test should still pass. All right, and let's move this somewhere else. I don't know. Does it fit in here? I'm going to say it's okay here. So it's the part that's common to both the old and new parsers. So just make sure that's okay. Move parse protocol definition to parse.swift. Parser protocol definition. Okay, old parser, let's see, to do, extract the strategy interface, yes. Parameterized method to set up the plugin capability. Okay, so here, this thing's hard-coded the parser. The question is, who's creating syntax analyzers? And this is where I'm not happy. It's not a lot of places. Okay, so what we're after, we've got this going on now. So we've got the strategy points to the abstract class, and unfortunately, we're creating the strategy. So in here, we're hard-coded to old parser. We don't want to be. Then the question is, what's the setup? Well, we have a number of setups, but we want them to not create the strategy itself. We want the setup code to create the strategy. Okay. And these, okay, well that's legit. These tests, I mean, there are a couple places that do it. Okay. I think I can live with these few places. Let's take care of this. Okay, so we're going to try and create a setup that looks more like this. Okay, so init, well, he hard codes that thing too, doesn't he? Syntax analyzer. All right, interactor parser. And he does it at an init time. He does set that up. Oh no, that's parse. He relies on this. Okay, let's move this out of here. Okay. Parser is type syntax analyzer. And we'll say this self dot parser equals that. Whoops. Equals syntax analyzer. Okay, that should still be okay, right? Yep. Okay, so I'm going to take this in a little smaller bite. Okay, so this, it's the parse that does that. Maybe this is the piece that's troubling me. This thing is the fact that we have to know the lexer to create the parser, and all that's being done here anyway. I almost wonder if you got asked for if you got the lexer instead. Let's push that through. So I'm saying instead of passing in the lexer and saving it here, let's pass in the lexer to the parse, okay? And certainly a way to do that is a little bit of duplication. Okay, so I want a lexer of type lexer. Okay, nobody's doing anything with this right now, so I'm just going to define it this way. Self.lexer equals lexer. Okay. No one's calling this one. So now all right, let's switch these over. So anybody calling this, we're going to move. Calling parse of line. Ugh. Okay, sorry, let's go back. If you call parse of line, you should substitute lexer of input. Okay, so parse line should be parse lexer of line. And so I'm just going to be mechanical here. You might decide these shouldn't come from here, and that's okay. We'll get there. Parse line should pass lexer of that. Okay, let's see if these all work. Okay, start changing syntax analyzer to take lexer instead of input string. I think that'll be better. Okay, in our search, parse of input, this can be lexer of input. Same here. And here. The thing to dislike is it exposes that lexer out at a different level, but I think that may be an improvement. So now our parser is much more focused on the token, the lexer, the tokens it gets, and the fact that they came from a string is not really the parser's business. But it does get more verbose, so that's a legitimate complaint. Oops. right, find usages of this should be unused. Program.program. Okay. That should be deleted. Pass lexer to parser instead of passing a line. Okay, why is that better? Okay, I think what I can do, I'm going to use this and say, I promise I will have a lexer when I use it. And I think because this is so small, we can inspect it and see that that's the case. That should build. Sometimes you have to put an exclamation point in the usages, but yeah, we're okay. All right. Now, I'm saying we should pass a parser in. And maybe I'm saying it's instead of the lexer, because now that's the caller's problem, is where does that lexer come from? And we don't use the lexers per se. It's only used because the parser wants it. So I think it's smaller bytes, but we're getting to the right place. So this parse method should take a parser. And we don't need the lexer anymore. Okay, so let's... Syntax analyzer no longer holds a lexer. All right, now this, I want to make a function that's just like it. And instead of a lexer, I want a parser. And I don't want to have to name it. Okay, parser. Self.parser equals parser. And parser.parse. Okay. Cannot assign value of parser to type old parser. That's true. This should be parser. Nobody calls this, so we should be okay. But anybody who passed in a lexer should be passing an old parser with that lexer. So let's see who used this. It's going to be these same line numbers. Okay, so old parser of lexer. Oops. Old parser lexer of line. Now, it may... I don't know. I'm not perfectly happy with this deeply nested stuff, but... yeah, I want to do this in a way that makes me happy with my choice. Let's say function current parser yields a parser, return old parser of lexer of input. So I'll need an input too. Okay, so that seems kind of useful. Instead of lexer sub input, we're going to call parse. Maybe it's even just parser. Parser of input. That will wrap it. And also it is implicitly deciding. So that's the other reason to like it. Okay. And I think this is a case where cannot call value of non-function type. Oh, I used that name already. Yeah, current parser. I'm going to accept the duplication. Am I? Maybe I'm not. One thing you can do in tests is define these extensions like this, just add stuff to it. And I think that might be the case, the way to go here. Let's make this let's say parser plus current parser dot swift. The plus usually sort of says, yeah, this is an extension. Extension. Well, it doesn't really need to be an extension. I'm just going to paste it, put that function out there. Usually the plus is for extension. I don't. Okay. Passing current parser, just a standalone function. Okay. We were in this one. I'm going to delete this and just use that bare function that's outside there. We'll need another function for the interpreter side, but I think that's a more complicated process. Okay, so test should run. They don't even compile. Hold parser. Oh, what if I messed up? Show the change. It was parser lexer line. Now it's old parser lexer line 1 2 3 1 2 3. Okay. Oh, did the same thing. Okay. Oops. Old parser lexer line. Okay. Let's see. We're partway through the change here. So who's calling this? Okay, so let's check in. Start changing over to pass parser to syntax analyzer rather than lexer. Okay, let's deal with these tests. Okay, they want a current parser. Yeah. Program. parser. And the reason I'm changing this around is I want all my tests to know which parser they're running, or sorry, I want my tests to not know which parser they're running, but somebody's got to be responsible to set up the parser we're working with. So I'm delegating that into that little current parser method. Okay, and here, nobody should be calling this now. Current parser, current parser, current parser. Okay, those are okay. This should be fine. Okay. This, I don't need that either. I mean, this is becoming ridiculously small. We'll decide at the end. This may fold back in. I think this just gives us a place to put that mechanism for setup. It's not doing enough work in the long run, but I kind of am willing to leave stuff a little ugly around the edges while I do the transition of one parser to the other. All right. Okay, so all call sites pass in parser to syntax analyzer. Okay, now parameterize method to set up plugin strategy. Yes. Okay, create the new strategy. All right, so now I've got old parser. I don't want to call it new parser, but let's make a file. Can I copy and duplicate? No. All right. Old parser, copy that. Let's make a new file. It's a Swift file. This one is, I'm going to call it basic parser. That's capital basic, the language. I think that'll be okay. Okay, so it is no longer old parser. It's now basic parser. And this is basic parser. It is a parser. It's completely identical to the other one. Okay. Let's do that. Nobody should care. Okay. Add new strategy basic parser. Okay, and so our testing, we can certainly run the new parser in our tests. Maybe an issue around interpreter. Okay, no, I guess it passes that through. So, okay. All right, no files. Okay, so I put that back. All right. Now the interpreter ones. So we in our tests we force the creation of the parser we want. The question I would have then is in the runtime, which ones do we create? How do we know what we're doing? And that's being done up here. Interpreter. Okay. It has a syntax analyzer. Wow, who who calls, let's find old parser. Okay, in here 4 times, yeah. Right, this, we initialize the program. We don't need the lexer, that's good. We just have the parser. Okay, I'm going to say when you initialize this, you should be passing in this you should be passing in a parser. Let's rename this field just to kind of keep ourselves from getting too tangled. Rename you to analyzer. Okay. And then here, I'm saying the caller should be passing in a parser of type parser. Actually, that's probably better as a first argument. Program of program. Maybe as a second argument. I'm covering all those bases. Parser. Okay, so instead of just passing me the program, you pass me a program, a parser, and the interactor that deals with output. And then this, let's go here. We need to use that. No, I don't know. You know what? I'm gonna not go that level in. I'm just gonna say analyzer. Whoever calls parse. Yeah, let's put a. I think I want to do that. And then I'm going to define my own current parser. I may need the line. And I'm going to return a parser. Okay. And an example of use. Well, this one. Okay. So, old parser lexer of line. I got one too many parens there. Okay, so I have a current parser method in here as well. I'm going to use that here. That means I got one too many parens. Okay. So now interpreter, let's go back up here. So this use new parser here is controlling the interpreter runtime. The one in here is controlling the tests. I'm going to say we leave this hard-coded like this, and the runtime has the option to use old or new. I think that's adequate for us. We're kind of a command line app in effect. We're just a compiler or an interpreter. So I think we're done in that sense. The interpreter can select old or new with a runtime flag. Now that could obviously be an argument coming in, or looked up in some sort of place. I guess I took out one too many parens. Okay, it could be coming from somewhere else and all that stuff. We could obviously make it a lot more sophisticated, but I think we're okay for now. It lets us test things and run things with the old or new parser. Okay, so I'm going to default everything to the new parser for now. Okay, and all our tests should still pass. Well, our tests like the old parser, but let's change this one too. Okay, and again, our tests should still all pass. Okay, so we're to the place where old and new can do what they need to. All right, and I'm a little puzzled. There's interpreter tests. Let's just take a look here and here. Oh, apparently that's not defined. Okay. Okay, so what we have is we have the switching mechanism. You can switch tests or production code independently. It's a manual change of flag kind of thing, or change this. So I think we've done what we set out to on the to-do side. We've created the new strategy. Okay. And we call it basic parser. Okay. And so I think we've put this in place. And now what are we going to do? Well, we're going to start moving to the parser combinator approach. All right. We usually take a break about halfway through or so, after an hour anyway. Let's take a 3-minute break, enough time to get a drink or whatever, and we'll come back, and using the new plugin side, we're going to start modifying that. And notice we have the same file in old parser and basic parser right now, but we're going to change it pretty dramatically. And the thing we'd like to do is, in this case, because we can call the old from the new, we can make everything use the old until we're ready with a new piece. And it forces us to work top down, because old can't call new, so we have to work from the top to make it work. But we have the top defined now, and we can go ahead and change things. All right, so see you in about 3 minutes. Hey, welcome back. I realized I hadn't checked in before we went. Provide a clumsy way to choose old or new parsers. And I think we ran tests, but let me double check. And let's make sure where we are. So we're running the basic parser here and the basic parser here, new parser. Okay. Run those tests. Okay. The reason I did that, I just want to run I want to run my tests. They're very independent. Um, they're all like check statements and so on. The parser tests just look at the tree, um, and the interpreter tests actually run the code. But in both cases, they're doing very high level tests that um, run the whole parser and look at the result. So I don't really have stuff that's specific to one type of parser or the other. It's they're legitimate tests for both. All right, let's get basic parser over here. Parser expression tests. I think we really want to go with statement tests. Okay. Or parser tests. Yeah, this is probably a better place to start. Okay, so what I have is I have all my tests are working. As I change to this new parser, nobody should be able to tell that it's using the new parser instead of the old one. All right, so let's see. I guess what's going to happen. Right. So the deal with let's pull this library in. And you know, I always complain because I just don't remember how to do it, but we're probably recently used. Yeah. Okay. So I got this parser combinator library we developed. It's up on GitHub. Don't know why it can't load the README, but we're gonna pull it in. Okay, add this as a library to target BASI. Yep. Okay. And we see down here, we got the main parser library. It's got a readme.md. Maybe it wants a plain old readme. But we have this parser combinator package, and the core of it, well, in a way, parse result is the piece we want to focus on. But there's a parser, and we're reusing names. I may regret this. Those names overlap, so we're going to see. We may have to do some changing. But anyway, so the core of this is there's an input type, and then there's a target type, which is the result type. And if you give me an array slice of inputs, which could be characters or tokens or strings or whatever, I will give you a parse result. And if it succeeds, the result is here's the target, the output type, and the rest of the input. And if it fails, it's going to return the position at which it failed and an error message. All right, and then the baseline parser is this one called satisfy that makes an assertion. You pass in a closure that gives you a Boolean result based on $0, the input value. So if you want to match a plus, your closure is token.type equals $0, or token.type equals plus $0.type equals plus, I guess. Okay, and that should be fine. Okay, so let's go to basic parser. And here's where we find out how badly it's going to fall apart. Import pcombo. Let's see if this complains. Because I'm using parser twice as a name. And, how does it disambiguate? I don't know. Like, it knows this is our protocol parser and it doesn't think it's the pcombo one. Okay. Let's rename that. I just don't want to deal with the clash. Okay, so protocol parse. Let's switch to parsing. parsing. It messed up, so I'm gonna have to see where. Parsing. Syntax analyzer. This takes parsing. And this one. Like, how many variations of the word parse can we create? Find up a parser. Current parser must return parsing. Did we get this one? No. Okay, so we included pcombo library, renamed our parser to parsing to avoid conflict, and I think that's fine. All right, now we have this library, and we even have the test, so we can see an example. Let's get to peak. Give it satisfy. Okay, here's a low-level example using satisfy. The satisfy parser $0. This one's satisfy over int. Okay, we probably want to do token for the most part, but it checks to make sure some value equals some specified value. That's fine. All right, basic parser. All right, so part of the difference is that if you remember, the input type for our parser is really array slice of whatever. So all this next token stuff is kind of different now. Okay, so what we need, let's go look at our lexer. It's got an interface that's, okay, you give it the string, and then you call, where's the entry? Next. Gives you the next token. Okay, let's keep that for a minute. All right, so the lexer, self.lexer equals lexer, that's fine. But the parse, the challenge is we got to keep the old way working because of our code, and then we got to keep the new way working for the new code. So we're going to run both at the same time. And yeah, so I think this, okay, let's go to lexer.next. I mean, I think what we really want is we want the lexer to give us the whole line of tokens. We don't need it for the other version, but we need a slice. All right, so I think I guess the other thing I should mention, this parser combinator approach really comes from the functional world, and so it tends to be very immutable, and it actually can backtrack if it needs to. So I guess, well, like somehow, if we're going to call a new style parser combinator, we better have this. It's got to be an array slice of token, and that's going to have to be initialized somewhere. And I think where it needs to be initialized is right here. Yeah, so that slice is going to have to be what's referenced by the new parser. I feel like if we can get the first one down, we'll be okay. But it's until we get that, it's a little bumpy. And I think, where do I get this? Well, I really want to ask the lexer, and I don't think that's an unreasonable thing to ask the lexer. Function line goes to array slice of token, and let's see, where's this normalize called? Normalize. Oh, it's done right away. Okay, so when you initialize the lexer, it normalizes everything. And I think I can just say, can I just call this? I guess in here is index is what's controlling it. Okay, so I'm going to say let starting index equal index. At end, I guess. I don't know if I can write it this way. Result.append token. Put the at end and restore the index. Okay, so and return result. So my claim is calling line should not affect anything in here, because when you call next again, when you call next, it's going to have had the index restored, so it's going to be back there. And the way these work is we always we always have various tokens, an end of line, and an add end. Okay, so token has no member at end. Okay, let's make this a repeat. I think that structure is okay. Repeat. What do we? Is it do until token dot type equals at end? No. It is type. Okay, let's. Okay, I guess I just convinced myself I need to TDD this. I was kind of hoping I could get by without it. All right, let's do lexer tests. Okay, so token sub 0 should be equal to num dot type should be dot number dot integer. Let's make this 2.0. Token 1 should be a print. This should be a number. We'll straighten out the indexes in a moment. 4 should be a EOL. And 5 should be at end. 2, 3, 4. Okay. Line knows all tokens. 10 print 2.0 should find integer 10, print number, end of line, at end. Okay. And let's just do that. Clearly going to be wrong because it returns an empty list every time. Not our business yet. All right, we return an empty list and tried to index it, so we get dinged. just stop. Okay. So now, what are you going to do? You're going to call next. Yep. Okay. So you're going to call let token equal next. I guess we got to make token a var as well. Token equals next. Result dot append token until token dot type equals at end. Okay. Capture the starting index. Oh, what's the matter? Is it do while? Do while is not allowed. Okay. I gotta look. Swift repeat until. Yeah, that's the while. Repeat while. Okay. Starting index. No, wait. Immutable value starting index was never used. It is used. I think it's just behind. Okay. All right. So we're gonna save the index so we don't mess up our line by calling a line on it. We're going to create a result set. Maybe I can swap these two even. Okay. We're going to read a token, append it to the list, and repeat that until we've read the whole line, and then restore the starting address and return the result. Okay. That should pass the test. Okay, now this thing. I'm going to say you should be able to say self.tokens equals lexer.line. All right. Storing all those tokens, and that should not break anything now. We're not referencing them. They should just get caught. Oh, no. Okay, how far did you get? Not very. Syntax error. Oh, interesting. Let's see. What happens on errors? Does it throw? No, it returns an error token. Okay, let's stop this one. Did it pass that one? Okay, so it's only this one. And it's an interpreter test. Oh, I'd kind of like to not do those. let's break here, run this test. Okay, we'll step over, in, run. I'm already confused. Okay. Gather data. Oh, something in there is not happy. Okay. Yeah, that's a little weird. So gather data runs through the whole program and parses each line. So calling this, let's make sure this doesn't break without this. If it doesn't exist. And nobody should be referencing it yet, so why? Okay. Why didn't it go into the constructor? I don't know. Okay. Go in. Okay. Okay. P line. Cannot find line. Oh, well, we think this is passing now, right? So that should be okay. What have I done? Two commented out lines. A lexer test. Let's go to the line here. Is this line causing the problem? I think this should just 0, 1, 2, and 3 should be wrong. But I don't see why it would freeze. Unless we're not advancing. I bet we're not advancing. Yep. Okay. Maybe this happened before. All right. So the difference I think going on is program sub index. If we go in number, notice it's incrementing index as it matches stuff. But I think we just and here's string. We skip over the quote. I think we forgot to do that. I think we just detected a bug in our lexer. Okay. Let's make a more basic test. Tests error tokens consume input. Okay, so let tokens equal lexer. That. think even .line. I don't mind repurposing this. And I don't even think I need both those. I think this will be enough to demonstrate it. This should be error. And 1 should be EOL. And 2 should be end. I don't even know if I need the line. Maybe it's better not to. Let's just do token. Okay. I think this test is going to fail. Right. And is not equal to end of line. Yeah. Yep. So it's not progressing after it returns that error. So let's go here. Default return make token. Let's do index plus equals 1. So we're always obliged to skip over the next token. Okay, here I'm incrementing index on an unquoted string. Yeah. All right. I think that's going to make this test pass. Okay, this one goes back to 2.0. And I'm going to run all the tests. And I think the gather data one should be okay now. Oh, no. Oh, that's a breakpoint. And continue. Okay. Ran all the tests. Yeah, it's so fast. Okay. Well, this definitely happens when you're doing this stuff. We found a bug in the old implementation. I'm imagining, I don't know if we totally missed a test for it. Okay. Yeah, our test isn't, this test isn't sufficient. It checks that you got an error for the unmatched token, but it doesn't check the next character. The next character to see that it's end of line or, that it's moving forward. So we do that now. All right. Good. Fix error where an unexpected character but doesn't move the index forward. Cool. And in compilers and interpreters too, it's not uncommon that there's just a lot more error handling code than you'd expect. All right. Where are we on our lexer tests? Okay. Line knows its tokens in line. Okay, that's good. Now we're back to parser, basic parser. We've commented this out. Okay, so let's try using this now, And again, this should it's supposed to be a non-affecting thing at this point. Okay, so I'm just going to try and nudge. This is what our new parser wants, is an array slice of tokens. And this is what everybody's looking for now. So I need to kind of manage that. And I think what I'm going to do, let's make a token index is 0. Okay. And I think, okay, that's fine so far. All right, trying to find that point where I'm crossing over into something that's going to create trouble for others. All right, so the thing is, I don't want next token. Well, we're kind of at the point of we've got to work out the interface between the old and new parsers. I guess that's what I'm doing at this moment. I have this new style array slice tokens. I set it up, and I could call it my new parser, and it would all be okay. But my old parser, it's going to be calling next token all the time. All right, and this may be... Okay. So I would like to... I want to use this token index, and when somebody asks for token, yeah, what if when you ask for token, token, let's try making it an array, an access to our thing. Token is if you get tokens sub token index. Is that going to work? Okay, lexer.next. Yeah, that part's... Lexer.next gives us a token. I think we just want to do token index plus equals 1. Whoops. And that goes away. Okay, so when you say tokens... Sorry, when you say token, you're going to be accessing whatever's at token index. Okay. And you're going to bump up token index. All right, let's get down into a... So they call next token. They don't call index at all. Does this work? That'd be a nice change if it does. No. How far did it get? Not very, but it did get somewhere. These all were unsuccessful. That does look odd. Line numbers required. Found read. Okay, it's like my first token's not right. Let's check our initialization. So, oh, yeah, we're calling it first. Okay, let's see. Where's single line? Where's my parse? There we go. Let's take this out because this is already pushes it to token 1 when we haven't started yet. So we've changed the way it primes. Yeah, I'm happier. Let's see if it works. Cool. Okay, and it's running fast. Good. All right, so before we had to seed the first token to get that variable initialized. Now that's being done by that token index being 0 to start with. So we were grabbing the second token to start with because we preloaded it, but now we're on the same line. Okay, and this doesn't need that. Okay, now that should still be fine. Okay, so make old parser work with array slice of token. I don't know, I had paperwork somewhere that would help me, but okay, let's see. Now, can we deal with single line? Okay, yeah, this is going to be single line is mostly handling the error stuff. Okay, it returns a parse, which is what parse wants to see. Okay, let's skip that. Okay, so I think let's see. Right. I think this is the point where we need to figure out how to wrap our old functions. So we would like to call line and deal with the error result, but the old style throws exceptions and we catch them and do something with it. The new style returns us that parse result that we looked at briefly that contains the index of the error token and the message. Catch. Okay, and it returns a parse like that. Okay. So what we're looking for, like we would like to say something like this equals line parser. I'm going to put parser on the end of each one of these just to be, I don't know, consistent across them and to somehow distinguish them. But single line parser is this new style parser. And how does it work? Well, it just tries to match the line. We don't have a line parser. What we need to do, what I want to do is something like this, wrap old of line, where line is the method going in and wrap old is it's a new function that takes the old line number parser and calls it and returns a parse result. Okay, but I think this is more of a leap than we're going to do in 10 seconds. Okay, so this is kind of, if I had the wrap old working, I would try that right there. But wrap old is not working, so we need to implement our wrap old. And let's create let's create some basic parser tests. I think I can live with that. New file. test case, basic parser tests. Maybe this is wrapper test. And I'm hoping it goes away in the end. Okay, so let's test wrap old with successful parse. And then we're going to need a wrap old with failed parse. And I don't know which one's easier. Okay, wrap old with successful parse. Let's take this out for a moment. And same here. Okay, it may be, I don't know, is the step too big? With a successful parse, well, let's go find something that looks like a very simple parser. Line is not it. We want something that's down on the bottom. Stop is a good one. Okay, so stop, it looks like line 10, stop, and it stops your program from running. So if you called, oh, that's too simple. It's got next token. We need one that's got a little helper method, but it's not very big. Go sub, go to. On this big. Oh, return. Okay, it's not much more than what we have, but return statement, if you well, there's no error there, so all it does is return successfully. Okay, let's check that one. So if I say wrap old, I don't know how I get to return statement. Return statement. The parse. I'm supposed to find this thing. Parse of return. No, it's got to be a token array slice. So it's dot return token dot make init line column type. Okay, let's try that one. Line 1 column 2 type dot return. Okay. Let's let return token equal that. Okay, cannot find return statement. Yeah, that's a tricky one. I don't know the way to reference it in Swift. Basic parser dot return statement. And this is token, return token. Okay, I think it's only complaining about wrap old. Okay, and now let's make our assertion. So we'll assert equal. Now we're looking at this return is different. It's the statement return. So parse. Cannot conform. I think that's just because it's not. Let's look at this. Return statement, and it's returning return. So I should be able to say statement.return there. It may be confused about which return it's getting to. Okay, let's do that. Should still complain about wrap old. Okay. Wrap old is function wrap old takes a function. Let's take it from here. It takes a return statement, throws, produces statement, basically. Tests. This doesn't need the return statement. It needs that. This is the function. Old parser of type void throws returns a statement, and it returns a parser, which is our new fancy parser. Oh, which means this is not the right assertions. Okay, so let's import pcombo. Okay. So cannot convert token to expected element type array slice. That should turn that into a slice. But this is really result. And we want to say result dot. Okay. What are we doing here? Return statement cannot be used on type basic parser. Did you mean a value of this type instead? Parse cannot be used on value of prototype. Use generic constraint instead. Okay. Parser can only be used as a generic statement type constraint. Okay, I think I can say what these are. It's going to be from token to statement. I think that may be what it needs. But I don't have a return value yet. Specialized non-generic type parser. Here's parser. It's got an input and a target. Okay, maybe I need to make this a class. Wrap old of token. No. Let's get this. Bind. Let me get satisfy. It's kind of a simpler one. Satisfy input type. Yeah, I think I got to do this kind of thing. Okay. Wrap old input type. Well, actually, I know it's tokens, so I don't even need that. But it is a parser. Okay, and if it's a parser, it should have constraints. It should know what it wants. Add protocol stubs. Yes. Input is token. And I'll say the target. I don't know. I thought target was a better name before, but I'm not as convinced. All right, does not conform. There's more stubs. Yeah, this is the guy we need. The target. Well, we can just say target because we said that was the same. Okay. Now parse. All right. So we'll need an init. Init, and it's going to take this. Okay. Whoops. And it's got to store it somewhere. Let old parser of this type old parser equals old parser. Okay. Oh, I've forgotten that so many times. Okay. This. Now, how do you parse? Well, basically you do something and you return a parse result. Result dot, let's just return a failure 99. I don't know. Okay, just to get this thing failing its test. We're still working on that. Okay, is this better? Now I'm saying wrap old. I'm passing in a function of that type, and I'm calling parse on an array slice. Let's say let tokens equals this, and let's see if it'll let us say tokens there. Sometimes it's happy and sometimes it's not. Okay, and I'll hold off on the assert. Okay, apparently this is a time it's not. It's unhappy about a lot of things, isn't it? Cannot convert token to a expected type that. Okay, so I can certainly do tokens ... I think we'll do that conversion. Type the target. Ooh. Is it like this? Or do I just say array slice and be done with it? Does that work? Gets the weirdest places for messages. The target could not be, oh yeah, explicitly do it, yes. This thing is going to return a statement. Return member cannot be used on type basic parser. Did I mean a value of this type instead? No. I mean, that sure looks like a void throws returns a statement to me. I don't know if I can trick it into telling me what the right way to say that is. Okay, let's see. Swift. How to reference a function on another class. It's not call. I don't know how I want to say this. It's like function pointer. I mean, in C it would be a function pointer, but let's see if we can. Yeah. How to pass a function pointer. a function reference. I don't think that's helping. So cannot find return statement in scope. Does it know where it is? Basic parser return statement. Let's just push it into the test. Okay, there we go. So I think what I'm going to call wrap old, it's going to be in that file that has the stuff in it already, so I don't think it's an issue. And I need to do assertion. So it's a parse result. So if case let success, I guess this is guard case, we expect to get a success with a statement and a slice of tokens remaining input equal result. If it's not that stuff, it's a fail. Except it's success but got result. Okay. And I think this is already far enough that it will fail. Oh, come on. Oh, third else. Yes, that's easy. We don't reference them. That's harmless. Okay. Whoops. Guard body must fall through. Okay, let's just do a return. Okay. This should fail because we hard-coded a return failure. Yeah. Okay. If it were to return a success, we would expect statement to be dot return, and we would expect remaining dot start index to be 1. Okay, because we passed in, it should have consumed the one at 0 and left us at 1 pointing just past the end. It's okay. That's kind of, you're allowed to point 1 past the end. You don't, as long as you don't access it, you're okay. All right. Now this should still fail. Okay. Expected success, but got 99, don't know. Okay. Now, if I let's just return a stop and 3. So I'm just want to validate that my wrapper cannot convert into success. I'm trying to validate my wrapper. Let's make this input, and we'll just return input. It wants a slice, so we got to give it a slice. Wrapper test target has no members. Stop. Oh. I guess it's easier to just make it do its thing. We got a failure. Okay. So what I want to do is call try. Since it throws, I have to be doing that. Takes nothing, and it returns a result. Try old parser. Okay, we're not expecting that to happen, but I expect this result to be result, and then where's that index coming from? Okay, the input. So this thing should. Oh, I don't want to get too crazy. I've got to find that token at some point. So, do I want to get tokens involved again? I mean, his original code was this. We don't have a next token, all right, but we could we make? Let's do the default input. Let's let index equal 0. Let tokens be array slice of token empty. No, just that. Can I make it force it? Okay, and then the test. Well, this is that's really what we want, is that. So let's define that. This array, I think we can just say dot 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 here. Is that going to work? Okay, tokens is going to be one token input. Okay, and the index is 0. So next token, let's do index plus plus. Plus equals 1. And I think in this setup you need to, oops, I don't know. My test is getting, this stuff is just Swift dealing with that return type. That is ugly, but it's acceptable. This part is getting messy. But I think this is token sub index dot dot dot. Okay, so whatever the current index is, we're returning the rest. Okay, and is that not okay? Cannot convert statement to expected type. Old target.target, aka the target. Where is it getting the word statement here? Result equals try old parser. I guess these are really the target. But I know there's statement. No, I don't. The target. This produces that, Okay. I guess we could just say target here. All right. Member of type, wrapper text cannot be used on nested type. Yeah, blending between these is the pain. Once we get through it, I think it'll pick up. It should all move quite a bit faster, but how am I going to get this thing? And the only way I know is my parser knows. You know, I think maybe we just have to pass that back as well. It doesn't matter if it's a bit ugly for now, but it's the thing that knows the state on that token index. Okay, so let's do that. Let's pass that in as well. It takes a while. Okay, so the init, I need to get the let's say basic parser of basic parser. And I will need to save that. Okay, and I will need to pass it in. Lexer return. Okay. Whoops. Wrong way. Now this goes away. All right. So let basic parser equals basic parser with a lexer on the word return. Okay, we wrap old basic parser dot return statement. Is that okay? This thing is basic parser dot tokens sub basic parser dot token index dot dot dot. You can't be referenced that way. Oh, insert basic parser. I always forget that. Parser. Okay. Result. Okay, I think we have a test. I even think it'll pass. Oh. Oh, tokens. Yeah, we can't do that. Basic parser dot parse. What does parse get called with? Unexpected nil. Yeah, this should be basic parser dot tokens. Okay, try again. All right, well, it's time to stop. Okay, well, good. I'll stop on a happy note then. All right, so we've got this thing. We need to look it over and make sure it's really on track. But we appear to have something that can take an old style parser, like return statement, and if you tell it the parser that holds it and this, then it can come back and find the statement that it returns and return it inside a parse result as our new parser expects. Next, we'll do the failed parse, and then we'll use that and try and wrap. I think, well, we're going to try and do this wrap line, and we're going to change this result handling to take a new style, deal with the new style results. All right. So thanks for joining me today, and we'll pick up tomorrow same time, which is 1 p.m. Eastern Time or 6 p.m. UTC. And I'm confident we'll finish this test fairly quickly tomorrow and get into the changeover on the combinator style. Make sure all tests run, but I'll push that and call it a day. So thanks for joining. Take care. Bye-bye.